Hello everybody, in this video we are going to continue our conversation about how to use the quadratic formula to do two things. Number one, identify how many zeros or x-intercepts our quadratic function has. And then our quadratic formula will help us identify those very specific x-intercepts or zeros of the quadratic function. So let me just go ahead and go through the steps of what we're going to be doing, and then we'll go ahead and look at an example where we follow these steps. So the first thing I want to point out is, in order for you to use your quadratic formula, your equation needs to be in standard form, and it has to be equal to 0. If it's not equal to 0, you're going to have to move those numbers and combine them with their like terms until there's nothing on the right side of the equation. Once it's in standard form and equal to 0, you should be able to identify the a, the b, and the c values in that quadratic standard form equation. Once you know what a, b, and c is, we're going to plug them into their specific locations located inside that quadratic formula. Once we do that, we're going to start with the discriminant, because the discriminant, depending if it's a positive, a negative, or a zero number, it will tell us how many solutions our quadratic function has. And if it's a no solution, then that tells us that we don't need to keep on going. But if it's a one solution, we will simplify that fraction into simplest terms. And if it's two solutions, I'll show you how to split the fraction so we can identify both of the zeros, okay, individually. And then the last thing, I am going to show you how to either use your graphing calculator, or you can use your online Desmos graphing calculator to check your work and to make sure that we're identifying the correct zeros of the function. So let's go ahead and look at our first example. All right, so our first solution is going to be a no solution, but we're going to treat it just like we would any other problem because we don't know there are no solutions at the beginning. So for this one, I just want to remind you that for a no solution, the discriminant of the quadratic formula will need to be a negative number. So when we get done setting this up, the discriminant is going to be this little formula underneath the radical. It does not include the radical, it's the little formula underneath the radical. So let's go ahead and look at what we have here. So this is in standard form, because we have the n squared at the beginning, the n in the middle, and the constant at the end. But if you look on the opposite side of the equal sign, you're going to see that it's not equal to 0. You have to have a standard form, and it has to be equal to 0. So we're going to take this negative 7n, and we're going to add it with the 7n to the opposite side. Now, because it has an n squared, we're going to combine it with the other n squared, which is at the beginning. And so this is going to, when we combine it, it's going to give us 2 plus 7, which is 9n squared, minus 6n plus 12, and this cancels out, leaving us a 0. Okay, so it's in standard form now, and it's equal to 0. So we are ready to identify the a, the b, and the c value. So remember, the a value is a number attached to the n squared in the front. So our a value is 9. Our b value is not 6, it's a negative 6, because signs matter. So that is a negative 6, and our c value is 12. So now that we have our a, our b, and our c, the first thing we're going to do is use this discriminant, and just the discriminant, because this is going to tell us how much work we actually have to do. So we're going to take our b value, which is negative 6, I'm going to put it in parentheses and square it, minus 4 times a, which is 9, c, which is 12. All right, we know that negative 6 squared gives us a positive 36. I'm going to bring down the minus, and then we're going to take the 4, the 9, and the 12 and multiply it. So it's perfectly fine if you want to type that into your calculator, because it could be a really big number, and in this case it is. It's 432. Now, if you take 36 and you subtract 432 from it, it is actually going to give us a negative number, which is a negative 396. So in this case, our discriminant is a negative number that automatically tells us that we don't need this formula. We don't need to replace the B's, the A's, or the C's and do all the work because we know it's a negative number. So in this case, we're going to say no solution. Now, if you wanted to, you can also check to make sure that this graph does not cross the x-axis, that you didn't get the discriminant wrong. So if you want to, I'm going to ask you to go to your home screen. We're going to hit 1. And if you have something up on your screen, just hit no, and then 2. Now, you're going to type in the equation that's equal to 0. So we're going to type in 9x squared. Now when you use your calculator, you can only type in x's. So we're going to change our n's to x's. Plus 12. Okay. And I'm going to hit enter. And you're looking at your x-axis and you can see that it doesn't even cross or touch. Now you don't have to use the TI Inspire. You can also use Desmos to check your work. Alright, so I'm going to show you Desmos just because it's a little bit more user-friendly than our actual calculator. And Desmos is something that you can also use on your STAR Algebra 1 test. So if you go to Desmos, you can click on the graphing calculator. Notice that I'm typing in my equation right here. And there's nothing on my graph. So I'm actually going to zoom out. And notice that our quadratic function is on top over here, on the top of our graph. Notice that it doesn't come down to touch the x-axis. So that means that our answer is correct. Our answer is a no solution because it doesn't touch the x-axis. So our quadratic formula is here to tell us how many and what are our x-intercepts for our quadratic function. So I'm actually going to pause right here. In the next video, we'll look at a one solution, and then in another video, we'll look at what it looks like to work a quadratic formula with 2 different solutions. So I hope this example, this explanation has helped. I'll see you in the next video.